Welcome to the start of a new series where ultimately the goal is to um, roast viewer submitted proofs, react to and roast in an educational, informative manner. But in order to get the ball rolling, I figured, casting stones in glass houses and all of that, I would start by roasting my own proofs. So we're gonna go back to the oldest. How do I do a full screen share? Uh, to the oldest proofs I have. Um, uh, that I could find on my laptop. I think I have some handwritten proofs stashed away somewhere that are even worse. Um, but we're gonna dive in blind reaction. This is from the semester that I first took topology, and and we're gonna look at my homework. So this is assignment one from fall 2015 topology. And we're gonna make fun of me uh the whole time. So get ready. Um so here right off the bat, this is hot garbage. I mean, the students I'm tutoring or TAing right now, most of their assignments are like infinitely nicer than this. They've got there's like nice headings and page numbers, and it all looks very good. And yeah, this is the trash that I was pumping out um, in my first semester using LaTeX. So, and you can see also, like, I think it's good etiquette to just repeat the question that you're proving. So I actually don't, for the other ones, for the other assignments, we'll see that I kept the question sheet, but I don't even know what the question sheet is for this. But you can see I think I'm very funny with the names that I put. Some things don't change. Um, yeah, so like here, I don't even know what the question is, right? Let X be a topological space. Oh yeah, before that, oh, okay, there's so much here to complain about. Um, okay, let's go in order. Let X be a topological space, and suppose A is a subset such that for all X in A, there exists a subset of A such that X is in U and U is open. And I guess we're trying to prove that this means that A is open. Yeah, that must be what it is. Okay. So yeah, the thing is, I was really obsessed. I know other like early students are this way as well. I was really obsessed when I was younger with being like trying to write everything in total formal symbols. Um when I first learned about doing this, but the truth is that is not a good way to write mathematics. It's not a clear way to communicate. This would have been so much better if I had just said these things with more words, you know. You could still use these symbols, right? But just like putting words in between each of these things, yeah, or such that saying in here there exists an open set of U, which contains X or something would have been a way better way to phrase this. Okay, so let's get into the proof for all X in A. Yeah, so that's really a no-no, right? So we're trying to prove a for all statement. So we don't really want to say for all. We want to always begin our proofs with let. So I want to pick an arbitrary. Actually, that's not true. Technically what I'm doing here is I'm constructing an open set for each X. So I would still write this differently. I would probably literally type out like for each X in A. Um, and then go ahead and say some stuff. Uh, God, but this doesn't even make sense. What I've written, I think the thing that I wanted to do here is probably the correct thing to say would have been something like let or how about this? Yeah, let's do it this way. Let X be an A, by assumption, we can choose, an open set, and now let's label this one open set U. Let's label this one open set U. So an open subset U of A such that X is in UX, right? That would have been the correct way, or a correct way to start this. And then we could have said from there something like, uh, you know, claim. So maybe I would have said claim. And now I would have tried to have done something like this, right? Proved that the union of all of these sets is equal to A. And then that would have concluded, we would be able to conclude from there that A is open because we've written it as a collection of open sets. So, yeah. Okay. Also, so blah, blah, blah. I try and say some other garbage like that. Also don't, yeah, I know. The therefore symbol looks cool. I agree, but don't. Just don't do it. It's not good clear writing mathematics. Yeah. There's maybe times and places to get away with it, but just don't. Just use your words. You've got words. Use them. Um, yeah. But look, I understand. I know what it's like. I know what it's like. I was there once too, as you can see, but just don't do it. Uh, Other than that, it's not bad. Yeah, so like, oh my God, let's look at I mean, this could be worse, right? But like this whole first paragraph is just very unreadable. You look at it first, and just the immediate reaction is, oh, I don't want to take a moment to understand that, right? Again, is really something like all those symbols that I've written there should appear somewhere, but there should be more words in between, spacing it out, right? So again, I don't have the question. I don't even know what it was trying to prove. I could probably, backtrack from the conclusion, right? Family topologies on X. We're proving that the intersection of some family of topologies is a topology. Okay, yeah. So again, it's worth in your assignment stating these things ahead of time. Oh yeah, something else I wanted to mention. Look, there's no like clearly here I'm starting a new paragraph and I don't know why there's no indentation. For those of you who have hung around my channel for a while, I've shown you my master's thesis and somehow I didn't learn this lesson. No one corrected me on that by the time my master's thesis, and it's so embarrassing because I think my master's thesis was all right, but uh, it's ruined by this terrible indentation. Uh, yeah. So again, look, there's this therefore symbol. This is just so unappetizing to read, and just by like, had I tossed in like seven more words into this paragraph, it would have been a much more comprehensible statement, right? And like, yeah, like this, let this, like, yeah, I guess it's supposed to be a collection of open sets. I guess that's not so bad. The way I've written it there is not so bad, but yeah, yeah. It just it could be better. Definitely could be better in those cases. Oh, look, here I actually said something. Um, yeah. Yeah, same here. Like, look at this. Do you really want to read this? Like your first impression, like be honest when you look at this. Are you really inclined to sit here and follow through logic? Again, just a few words. Maybe, well, is this okay in this case? We're trying to prove these things are topologies. Ugh, ugh, yeah, I don't know. I don't know. So you can see this is where I was starting from. Not actually where I was starting from. I was, I was worse than this, but this is the earliest thing on record I could find to start. So, um, yeah, yeah, let's see. Yeah, and also like expressions like this, expressions that are big like this, like definitely use slash left and slash right on your braces. And I would make this in display mode. I would use the double dollar sign in between these here. I think that's a way better approach. It really helps readability, especially since like this isn't like 1950. We're not worried about how many pages our paper are going to be for the publication. Except I think there's some journal that only publishes like two-page papers or something. This fun outside of if you're not publishing there, especially if you have big expressions, just space them out. Use the space. It's easier on the eyes. It's way more readable. Um, yeah. Yeah, I don't know how much more I want to say about assignment one here, but yeah, you can see uh, it's not the end of the world, but yeah, roasting mountain proofs, garbage. Let's see assignment two. I had a quick glance at it. This looks a little bit better, but almost I would say that Um, in the first part of this, I'm maybe suffering from the opposite problem. This looks this looks pretty verbose. This looks too verbose. This is the opposite problem. At least I've said here what this is. So page 92 from Moncrie's. Maybe I can open that up here. Try and find page 92. Let's see. We're getting close. 91, 92, question 8. If L is a straight line in the plane, describe the topology L inherits as a subspace of RL. RL. Oh, so I guess that's R sub L is supposed to be the real numbers, but on that line? Cross R as a subspace of RL cross RL. Actually, no, now I don't know what that means. I'm not sure what RL is supposed to mean here. Regardless, we can dive in. Yeah. So now I'm experiencing, so I wonder even if I don't recall this happening, but I wonder if my professor said something to me at this point and was like, Kristaps, it's way too technical and symbolic. Use some more words. Consider a line L in the plane and the topology it inherits. If L is a vertical line, the subspace topology will be the same as the topology on the real line. Oh, that is just awful. Why? What's the claim? And what do you mean the same as the subspace topology? Why? What's the proof? Like, mm. and vertical line, like yeah. So how I would start this proof off today is first off, I would talk about like the equation of a line in the plane, right? So I would say something like uh, let what is it, L, or was it uppercase L, be the line defined by the solutions to, and I don't know if we're working in let me see, let's go back here to the question. If L is a vertical line, so I'm guessing this is R2 or something. Uh, but so we could write it AX plus BY equals C, right? And then instead of saying, oh, the vertical line, right? I would say something, where I guess we want not all of these to be zero. Um, but yeah, so if I wanted to consider the case of the vertical line, of course, that's when we just have y. Y is like a free variable, right? So we'd say something like consider the case when b equals 0 or something, right? That'd be a way better way to go about that these days. Yeah. Yeah, and you can see, I mean, this is so much the opposite problem. Again, no indentation on the paragraphs, terrible. For any other line in the plane, there exist boxes which intersect the line so that the line runs through the left side of the box. That's just a claim. Where's the proof? I didn't prove anything here. I just stated it. Uh, yeah, garbage. This is a sketch of a proof. That's what this is. Um, yeah, so this is terrible. I hope I got 0. I hope I got 0. I didn't prove anything. Uh, yeah, yeah. Throughout this question. Ooh, oh, oh, oh. This is, I mean, I see what I'm trying to do here because we have intervals, so I'm trying to not conflict with this, but instead of saying that this is an element of here, I again would just maybe be a little bit more careful to explain. I would say something like um, we denote elements of X product Y by, little x product Y, where X is in X, Y is in Y. Or even say that in order to avoid confusion with interval notation, right? So explain why are we making this like, yes, it will be clear to the reader, but just say it. Just say it, right? Why are we making this weird notational convention? You should justify why we're making this weird notational convention. So in order to avoid confusion with the interval notation, um uh we will uh denote the ordered pair xy in x cross y by x times y, right? That'd be a better way to do it. Um, but yeah, if you're gonna make these assumptions, tell the reader why. This is a bit better though. We can see I've improved in the next assignment, right? There's a little bit more words, by the example done in class. This is a basis for the discrete topology on R by theorem 15.1 dot 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 is a product. Yeah, so here starting to improve a little bit, right? I haven't written everything in just strict propositional calculus symbols. It reads a little bit more. It's not so daunting. It's not so daunting. If you really want to go the extra distance, of course, pictures aren't proofs, unless you're doing string diagrams for category theory. But I would, in a topology assignment like this too, I would draw some pictures if you got yourself a writing pad and a stylus. Why not? You want to go the extra distance? Uh, yeah, yeah. Again, same same deal here, but this is looking better. This is looking better. I'm slightly less embarrassed. Ooh, don't like this notation. Don't like this notation. Yeah, just say, just say, don't be lazy. Just say in words that use open. I see we're slipping here. I see we're slipping here. Oh, yeah, I'm being lazy and yeah, just too much symbols again. So we were better for a bit. We held it together for a bit. Maybe I got in a time crunch and gave up on being nice. Again, also here's a place like a bunch of these lines, right? Stuff like this. This overline, whatever. These are things I would make display mode. I'd use the double dollar signs. Just to aid in readability. Mm, yeah. Anything else worth pointing out from here? Yeah. I mean, what am I using? God, what did I use to make that? Did I use like slash big triangle or something? That is not a delta. Uh, that is funny. That is funny. What a guy I was. What a time. Yeah, okay. I mean, I think that's pretty cool. Let's jump ahead to assignment 5. Let's see if I got much better in assignment 5. That looks better already to start. I'm interested. Yeah. Again, well, maybe this isn't the worst, right? Writing CTS on top to mean continuous function. Not a terrible idea. I think it can be worth just saying the words, but also this notationally isn't correct, right? Because like what is n? Um, what is n? And this makes it look like I'm taking like one fixed function. So how can one fixed function converge? I would say something like this. Nowadays, I would maybe say something like let um uh maybe for each n in n, let f at n be continuous, and suppose that f sub n, maybe like this, converges uniformly to a did I assume it to be continuous? I shouldn't assume it to be continuous, right? Because I'm probably proving that it's continuous. Uh, to a function, and then yeah, I'm proving something about it. Use this to prove that f is continuous. Yeah, so to a function, let's just say it converges to a function f x to y. So that's maybe a more reasonable way to write it. Uh yeah. And again, yeah, this is also looks very cluttered, right? Especially with this whole expression in inline mode. Again, I would use like align mode. I would use display mode with double dollar signs, maybe just to give it more breathing room. Uh, yeah, okay, I'm being overly symbolic here as well. Typical, uh, I guess I don't want to make you too bored of just talking about the same mistakes I kept making and will probably make for years to come as we chronologically um, crawl through. Oh, this is 2017? Wow, I thought this was like 2015. Yeah, I guess maybe I wasn't taking topology in 2015. Um, wow. What is this garbage? I just submitted. Oh, this is bad. This is bad. This is horrible. What did I, what is that doing here? Is that supposed to be a proof inserted halfway? What have I done? Why is that there? Oh, God. I can't believe I'm uploading this to the whole internet to show you guys. Oh. Bad, bad, bad. Also, by the way, I mean, this is a general topology course, and maybe it's clear from context that these are supposed to be metric spaces, but I didn't say that X and Y are metric spaces in here. So, that's an important part. You should define all your terms, define all your symbols. Um, yeah, and like for example, here I talk about D. What's D? I didn't say what D is anywhere, right? Like I should say, okay, I guess maybe that's the D ball, but what the D sub X ball or something? Yeah, it's undefined notation. So this is terrible. I mean, fail F. I give myself an F on my topology assignment 5. Uh yeah, what else we got? Yeah, okay, just looking over this, I don't know if there's that much more I want to say, but um let's look over now at my final project. Ugh. Awful. I mean, okay, look. The final project was not meant to be like a project in the traditional sense, where you do have some exposition or something. The assignment was, as I recall, it was just like do a list of problems from the book. You had a choice of your chapter, and each of the chapters you got to pick which uh questions you were going to go through, which set of questions you're going to go through and do. So I went and I went through the questions for the chapter on algebraic topology. So I thought that was really cool. I wanted to learn it more. But still, even though this wasn't meant to be a project in the way that most people understand it, so much as just a list of exercises, there could have been more exposition. There really could have been more exposition here. But so what to say? I mean, things could be worse. Things could be worse. It looks like maybe I improved between this and the final assignment. Nothing nothing stands out to me. It looks like, just at first view, there's a good mix of symbols and words. Thank God I didn't try to shove this in inline mode or something. So not terrible. Yeah, again, I didn't really God, what am I trying to say here? Yeah, this is another case, more cases where um it would have been helpful to just uh actually say some things with words. So but this overall, skimming through this now, this is better. There's more spacing. Oh, you know what's a good thing? Here's a good tip. If you're submitting this for homework, I would use 1.5 spacing. It just especially if your TA or instructor is going to be marking with pen and putting in between the lines, it's helpful, it's nice. So it looks like I was starting to do that here actually. Even if they're doing it on Gradescope or something, it can be useful. So that's a pro tip for you there. Yeah, look, this is better. This is better. I mean, there's a mix of words and symbols in a nice fashion. Doesn't look too verbose, doesn't look too symbolic. So just as a quick overview, yeah, not so bad. Not so bad. So um yeah, I mean, some of this stuff gets messy. I would probably use align mode here. Also, it doesn't look like I explain very well why these things are true, but um, yeah, yeah, things are better. Following diagram commutes. Nice. Oh, that was a gross looking diagram. Wonder how I made it. Those arrows look weird. Um, yeah. I guess that's all for today. I guess that's all. Wow, this was a big project. What else can I say? Oh yeah, by the way, so more, I mean, I've already said this a bunch before too, but also especially if you have things with fractions in them, display mode. Just do it in display mode. Um, it's easier to read, much easier to read. Ah, here we go. Nice. Okay, look, I listened to myself. Somehow I knew I was making this video in the future. So even though the proof, you can see I still worked to make a formal rigorous proof, but I added in pictures to assist in the understanding. That is awesome. Okay, I give myself an A plus for doing that. That's always a nice thing to do. So don't rely on the pictures for any amount of rigor. Do not refer to them for any amount of rigor, still do everything formally, but adding those pictures can be really helpful. Um, Nice. Awesome. Look at that. Wow, great. I improved so much. I improved so much from the start. And yet, as you can see, there's so much further I have yet to go. So I think we're gonna call it there. If you want your proofs roasted by me in the future, I'm gonna put my email, the channel email down below. I'm also going to start opening up my email for tutoring. I'm probably going to charge a lot because I don't have a lot of time and I need money. So um, you can also email me about that, and I will help you write better assignments than this. I promise. Anyways, take care. Time to go. Time to go prove some more theorems.